Ah, the infamous big red button. Boy, do we see a lot of these things. And in this video, I'm going to do in real time, so feel free to fast forward, I won't feel bad. I'll do in real time adapting this inexpensive push button to be an adaptive switch. So what this started out is a toy that I just learned about from my good friends at Make Good Design that is designed to record your voice and then teach your dog or cat to speak. Like, I want a treat, and they press the button, I want a treat. So there you go. I have never seen such a thing before, but stranger things have happened. So let's take a look at this thing. We're going to convert this into a regular kind of adaptive technology switch using a 3.5 millimeter, aka 1/8 inch mono jack. And this is one of those notorious packs that you can get on Amazon. You get, I don't know, this thing has like 4 of them. They're 3 feet long, and they've already got the leads cut and tinned, so they're really giving you a good jump start there. So when you're doing this stuff, buy the pre-made cables off Amazon. There's no point in making your own. It's just not worth your time. And and the set of these, I think a dozen of them were about $36. So what is it, about $3 each? So pretty inexpensive to mess around with and teach people how to solder and adapt stuff. So the first thing we want to do is figure out how to get into here. As is classic, these things have little rubber feet on the bottom, and we have to figure out how to pry the little rubber feet off. And there's one. And here, I'm just using my fingernail here. Now, you could also use like a lot of the times I'll use like a pick, like that. I'm being somewhat destructive with this because I don't really intend on having anybody use it, but set aside your parts just in case you want to put together nice and neat. Always a good idea. And then looks like 4 little Phillips screws here, so I grab my Phillips screwdriver. You'll notice as I'm doing this, I have not taken out the battery cover. I already know there are no screws underneath there, and I'm not going to be putting batteries in here since I'm just using it for the switch. So there we go. Okay, so now we have the 4 little screws that we need to put aside so that we can put this back together again. 1, 2, 3, 4. And let's see how this works. So you have this, and look at this cunning methodology for a spring return. Instead of a spring, they're using a piece of foam. So that's kind of interesting, a way to save money, that's for sure. And then here you have, for a $3 toy, this has a lot of complexity inside of it. What you've got is this section here with the metal thing and the 2 gray wires. That's the speaker. So that's where the sound comes out of. I have no idea what this sounds like because I actually haven't powered it up yet. And what's interesting, and I'm seeing, and you're going to see this constantly. Let me zoom in a little bit on here, and hopefully we can get a better picture. Let me turn off that. That's a little too much. But you're going to see some versions of these boards are going to vary. Some will have these test points. Like, this is really good. It's got a whole bunch of test points all over the place. So trying to utilize this is really not going to be bad. I mean, look, and they're even marked. It's ground, VCC off. And then you have the push button itself, which goes over to there. So what I think on this one, since your board may not have these additional test points, I'm not going to rely on them. Now, I can tell you right now that what these test points are over here are for programming this chip. This is a microcontroller, and they have to program it. So what they have is they have a robot come in, or a human being, and they press test leads against these points, and they have it hooked to a computer to program it. So that's how they do that. So So you have a couple of points. You got PB0, whatever that is, another VCC, an unsoldered connector. There's even another. Oh, that's the microphone. There's a microphone here so you could record your voice. So that's what's going on in here. Now, for adapting this specifically for this purpose, what I'll do is I'll tie into one side of the switch or the other. These switches are mirrored, so these two contacts work together and these two contacts work together. So when you're looking at these things and you want to put in some wiring of your own, look to where there's less stuff around it. Now this one, both sides, there's really not a whole lot of stuff blocking my view, so I could use either side. I'm going to choose to use this side just because I feel like it. Now, to adapt this, the first thing you're going to want to do, or not the first thing, but one of the things you're going to want to do is heat up your soldering iron. Now, this happens to be a little battery-powered one I use for my demos, but you'll want to use a proper soldering iron because these things chew through batteries pretty quickly. But handy for videos. So what I'll do is I let it heat up a little bit, and then I touched a little bit of solder to make sure it's hot. Now that smoke that you're seeing, that is actually, there's rosin in the solder, and rosin is a chemical that cleans the joint. So what you do is apply the iron and the solder, apply the iron and the solder. And my light is really horrible here, but there we go. So I've added two little solder blobs there, so I've added additional solder to those two contacts. So that gives me something to work with, because normally on a surface mount component like this, the solder is underneath, so you can't actually, there's really not enough to attach a proper wire to. Now, you don't want to go attaching your wire right away. Why not? Let me turn this off, because we need to figure out how we want to route it. So we need it to go inside the case somehow, and I don't really want to mess with, I want this thing to still work normally, so I'm not going to go through the battery panel. That's a place I would go often because it's got space to go into. But so for this, I'll probably just go through the bottom. Now, bottom is not ideal because then it won't necessarily lay flat, but this we're experimenting and playing with. So what I'd probably do if I really wanted to do this super properly, I'd probably go in through the side of the button here. Now, let's drill a hole. Drilling a hole, for this little stuff, let me adjust the camera a little bit. For this little stuff, often I have a little inexpensive hand drill that I use. And with drills, you always want to start out, especially with plastic, because plastic will crack. Start out with a smaller bit. So the bit that I have in here right now is a 1mm bit. And the wire is not going to go through there, but it gets me a starter hole. So there's my starter hole. And then I'm going to put in a larger bit, which is, this is a 3mm bit, which happens to be the diameter of the wire that I'm using. So this should be pretty close to what I need. And what I did to show is I had my digital calipers and I measured the wire that way. So I know I need about a 3mm hole there. So digital calipers, very, very handy if you're making stuff. So I've chucked up a 3mm into here and just kind of drill it out. Take your time, and you can kind of do a test fit and see if it goes in. It's a little bit tight. So in this case, I could either go with a bigger bit, I could wiggle it around a little bit, but the other thing I have had, and this is such a useful tool, I've had this for ages, but this is a model maker tool for like professional remote control cars. but it's designed specifically to ream out, to make holes kind of very gently and very slowly, so you could gradually expand the size of that hole. It's almost like a step bit, but it's specifically designed for plastic. And see, now that cable goes in there quite nicely. So let me give myself a little bit of lead. And we know that folks are always going to yank on cables. So what we want to do is we want to prevent this cable from being yanked out. The easiest way is to just do the most basic slip knot and go like that. Now, a lot of the times what I will do is I will use zip ties or cable ties in an X pattern and do that, because sometimes a knot will mess up your could hurt your wiring and things like that. I don't usually like knotting wires, but we'll do that for this because it's just experimenting. And then we're going to solder these two wires, and we're going to solder one wire to the one little blob we added and one to the other. And so let me heat up my iron again, get that battery powered iron going again. And this is an example of where you need a lot of hands. And I wish we as human beings had like 4 arms, because I could really use them at times. What I'd recommend here is hold it down with some blue tack, some silly putty, some clay, something like that that'll hold it down. You could also get spring clamps that will hold it down, so that your wires aren't moving around. Because I will tell you, the number one annoying thing with trying to solder is having those wires move around. So you can see what I've done. I have that blob already in place, right? And I'm just going to heat up that joint. It remelts the solder, hold it down for it to cool. And that's that. I mean, it's so easy. It's not so easy. I solder thousands of joints a month, probably a week. So I have a lot of practice at it. So there's my kind of okay, good enough soldering job there. It's got a knot to provide some strain relief, and at this point I would test it, and of course I don't have my thing to test. Oh, maybe I do. Hold on, let me go over to the other side of my shop. Fortunately, my shop is my office, so I've got plenty of room. This is a little switch tester I made, and it's battery powered, and what it does is it lights green when it's on, and then you plug in your jack, and then you press it, and you can see the little yellow light is going on there, and so this button is working. So I will have to hook it up to something else to actually test it, but so at this point, so if you could make your own tester, or you could use a toy as a tester, have a tester. It's another good point. Have a tester and have a known good switch, so that you know if whatever you've adapted is working properly. And then the only other thing with this is I'll just kind of flop this back together, realign the holes, and then screw it back together. Maybe put the feet on if I wanted to. I'm not going to do it because that's usually the fiddliest part, and this video is long enough as it is. But that's that. So the other neat thing is this, it should not have affected this unit at all. So it'll still work the way this was originally designed to work, but it's also now can drive other things. Now remember, when you are using this to drive other things, you do not need batteries in here. You do not want batteries in here, because you might make strange things happen. So if you're just using this as a switch, don't have any batteries in here. Make sure not to do that. So if you fast forward through the video and you watch any one thing, just remember that. Okay, so find the sides of the switch, put a little dab of solder on them, drill the hole, route the wire, give it a knot, hold it in place with your finger with some blue tack and solder it back and test it, and then you're good to go. I hope you enjoyed this switch modification.